Welcome back to CSConnect series. We are going to have an introduction about digital electronics. We will just have a recap of the previous video. So we know computer science adapts all the concepts from the science concepts, and now we will pick up physics from that. In physics we have a branch called electronics. What is electronics? Any device that uses electricity will come under electronic device. So when you want to operate an electronic device, obviously you will need electricity, and there are also chargeable electronic devices. So this is something like you need some charge to make it work. In electronics we have a topic called energy band structure. Energy band materials, what are they? Some material may allow electricity to pass, some material will not allow electricity to pass. Say for example, they will say while working with electrical circuits, try to wear a rubber slipper or stand on some wood. If this is going to be wood and this is going to be earth and you are on top of it, electricity will be conducted from earth to the human easily. So that's why they ask you to stand on some material called wood so that the electricity will not be conducted. You will not receive shocks that much often. So this is what they mean by flow of electrons. So when I say earth is affecting the human, it means there is a flow of electron. So there are three classifications. We call them as conductors, semiconductors and insulators. What are conductors? They allow easy flow of electrons. It means earth can anytime affect the human standing here. There is a term called insulator which is completely opposite to the conductor. It prevents the flow. So you can say wood is an insulator here. In fact, if you take wire, some copper cables or something, these strings are the actual conductors which carry electricity. The outer layer is what we call as insulating material, which will actually prevent the flow of electricity. Then what about semiconductors? They lie between conductors and insulators. It means they allow the flow of electrons as well as they can prevent the flow of electrons. Both the works can be done by semiconductors. We can say something is on here and something is off here. This on and off concept is similar to a switch. So when you press down the switch, it is switch on. It means you have current flowing to any light or to the fan. When you just press it up and make it as off, it means you are stopping the flow of electrons. You can switch off the fan, you can switch off the light, you can switch off any appliance. This basic on-off mechanism is what semiconductors do. So this is like background of digital electronics. Now we will see about signals. There are two kinds of signals available. One is analog signals and the other one is digital signals. An analog signal is similar to a current, similar to electricity. They are continuously varying. It means if you have a copper cable here, this electricity here is actually continuously varying. So that's why they used to say don't touch it, you may receive a shock, because the electrons keep flowing on. So such signal, whichever is continuously varying or continuously going, will be categorized as analog signal, and there will be an infinite number of values in a range. Say we take the value as per this axis, it is 0 and here it is 2. Now what are the values possible here? I can just say this is 0.5, this is 1, this is 1.5. It doesn't stop with this. You have 0.1, 0.2, 0.3, and between 0.1 and 0.2 you again have 0.111, 122 similarly. So there are infinite number of values in this range. Here we have taken 0 and 2. Similarly, if you take any range, there will be lots of values running inside. Now we will take an application, an amplifier. Somebody is talking in a very low note. So they will amplify the particular audio to make it in a loud note. So here the input is also in the form of waves and the output is also in the form of waves. But see the intensity, it is so low here but it is so high here. It means it has ups and downs very clearly in the output. So just take it as volume raised here and this is a normal volume one. Every wave will be raised and lowered. You take this wave, it is raised here. If you take this down wave, it is lowered here. That's what this example means. And next one, a filtering example. Take the blue colored wave to be a signal or some audio. Take the mustard colored obstructions as noise. When you filter noise from the signal, you get a clear signal. You can just imagine a song recorded in a very crowded place. You are removing the crowd sound completely and the song is clear now. So you have to take real-time example to understand what is being given here. It means it is continuously coming and continuously getting rectified and moving. Now what are digital signals? So digital signals take only a limited number of values. So what are the values? I said a semiconductor has two values, namely on and off. When you on, the current passes. When you off, the current doesn't pass. That's what we mean it as on and off states. So here state means it is in a particular position. When we say it's on state, it means it is flowing. When we say it is off state, it means it has stopped. So this on and off can also be termed as high and low. So when we say on, it is 1. When we say off, it is 0. Here they have given 0 in the lower part and 1 in the upper part. Anything below the line falls under 0 and anything above the line falls under 1. How can we technically name them? So when there is a 0, we can name them as circuit in off stage. It has a low voltage signal and it's an open switch. Open switch in the sense you are switching off. We will see about 1. So 1 is circuit on, high voltage and closed switch. This is like switching on. You are pressing it down and closing the switch. When you press it up, you are opening the switch. Now you can ask me, on means the current is open, but you are saying it is closed switch. Why is this contradicting? When I say open, you are not allowing the electrons to pass from this side to this side. You are breaking the connect. But here when I say it's a closed switch, you are allowing the electron to pass on this line. So closed switch means electricity is passing on. Open switch is electricity is cut. I'll give you two more diagrams here. Take this to be a LED bulb or something, and here it's the battery connection. We have plus and minus here. When we have open switch circuit, this current will not pass here and the bulb will not glow. But when you take a closed switch like this, electricity will be flowing very easily. So from where the charge is producing, it is produced from the battery and it has to travel this way. Since it is open, it will stop here. But here it will generate here, it will come, pass through this side and it will be supplied to the light here. Getting back to the flow chart. From physics we had electronics. Based on the signals we are classifying electronics. This classification is going to give you the connect between physics and computer science. The first electronics will be analog electronics. This deals with analog signals. And the next electronics will be digital electronics, and this deals with digital signals. Now this digital electronics, it is connected to electronics and electronics is a part of physics. Now under digital electronics, the first topic that we are going to discuss will be digital systems. So what is the work of digital system? This manipulates discrete elements. What are those elements? They can be electrical signals, they can be any digits, they can be any letters from the alphabets, they can be any arithmetic operations. So far we were seeing discrete elements as 0 and 1. Suddenly if you see, there are lots of things. Discrete means they are not continuous and something is picked from the lot. So when I want to form a number, I'll pick something in between 0 and 9 and form a number. Say for example 1, 2, 3, 2, 5, 6, anything. Whatever I want, I will pick only from this range. So this is the limited set of value. Similarly, alphabets, we have A to Z, lowercase or uppercase. Any word that you want to form will be from this 26 letters. This is with respect to English. Take any language. You will have letters only from that language to form words or to frame sentences. You have to depend on those letters only. So that is discrete values. So you can ask me, if arithmetic operations are discrete, then what operations are continuous? Go to calculus, you will have this 0 to infinity symbol. So this differentiation, integration, they keep on running. So these come under opposites of discrete elements. Discrete elements are represented in a digital system by physical quantities called signals. So the signals in present day electronic digital systems will have only two discrete values. So one is 0 and the other one is 1. And these two numbers are called as binary numbers. And why is computer science all about 0 and 1? Because it is a part of digital system. In digital system we have digital signals, and in digital signals we have only 0 and 1. That's why computer science is with 0 and 1. We'll see a small example for discrete data values. So I was telling you how to form a number and all, right? We will see a small application. Payroll system. Just take an Excel sheet. You will have employee name here. Then you will have their salary here. Then you will have some address here. Take something like this. When you want to fill employee name, what values will you pick up? You will pick up only something between A and Z. Similarly, when you want to mention salary, what numbers will you pick? You will pick something between 0 and 9 from digits. Whatever number you form here will be between 0 and 9. There are no other representation. What is 10? This is 0, this is 1. When it is written this way, it is 10. What is 999? Anything with 9. So except those 10 symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you don't use anything else, right? And special symbols. So certain people will write plot number 6. These are some special symbols, and when representing some kind of currencies also we will represent this. So here it is dollar symbol. Discrete values means values taken from a specific or limited range. Now we will get on to digital computer. So this digital computer is not only for computation purpose, it is for many works. Discrete is for 0 and 1. In terms of digital signal, this is for the computer system. And the discrete values I said, like name, salary, this is for our purpose. This is the representation of the signal that is sent to the computer. But do we understand this? No. Instead, we go with this form. But again, we pick up values only from discrete set of elements. Now, if you take digital computer, definitely there will be something to be given as input and something to be taken as output. So, input is given to the memory, and from the memory, after finishing all the processes, we are getting output. This memory will be interacting with processor, or what we called as arithmetic unit. Computers were previously used only for computations, mostly some kind of calculations. So arithmetic unit is specified here, and they have interaction in both the ways, and these two units are connected to the control unit. So this control unit will manage overall thing. This is the basic architecture that was given in old kind of books. Today we have something called central processing unit that combines the control unit as well as the processor unit. So central processing unit will combine these two works. So we have something called CPU here, we have input here, and we have output here. Then they say these two will be taken care of input output processor, IO processor they used to say, and this will be connected to the CPU, and CPU will be connected to the memory. Books published before 1980 will have this diagram, and books published after 1980 or 1990 will have this one. We know something is input, something is output, but overall what are they? Those input output storage system are what you can touch and see. They are called as hardware. The physical and the visible components of your system is hardware. Then in order to make the hardware work, you need something else. Imagine I have a keyboard with me, a mouse with me, and a display with me. I have connected everything together. What gives life to the hardware? Software gives life to the hardware. It makes the hardware to work. So the set of instructions that will enable the hardware to perform some tasks. So hardware, whatever keys I press will be loaded. So in order to accept that as input, I need a software. Software and hardware together, they make a computer system. So we will see the hardware equipments here. So these are input devices, these are output devices, these are storage devices, and these are some internal components. The DVD or CD writer is here, the RAM is here, then we have the motherboard, then we have the chip here, then we have the cooling fan here, we have hard disk here, we have SSD here, even they have taken the complete processor here and the display unit also here. So these are the hardware. Now what about software? In softwares we have two kinds again. One is system software and another is application software. This system software is needed for the hardware to respond, and this application software is needed for us to get our works done. System softwares include operating system, then device drivers, the associated utilities, the firmware, and the programming language translator. You need not go for some high level language for this. You can take hardware level languages as this particular translator. So anything that makes the hardware work will come under system software, as well as it will give you an overall environment for you to work. What about application software? Anything that you install on top of system software is application software. It can be a web browser, it can be a word processing software, it can be a gaming software, it can be a graphics software, it can be anything. So anything that is installed upon system software will come under the category of application software. Now we'll have a small change in this diagram. So we have hardware and we overall covered it with software. Now we'll differentiate system software and application software as layers. The first layer will be system software. It is necessary for the hardware to work, and the next layer will have application software. We are just changing the title as categories of computer education. Computer science is about learning hardware, learning system software, and learning application software. So hardware is what we saw in the diagram. So we had input here, we had output here, then we had central processing unit here. How the processing is going to happen between them is also computer science. Between what the process is going to happen is also computer science. And what does this part alone is going to do is also computer science. Here we are saying categories of computer education. I often come across a question. Why are there so many courses of computer science when everything is going to teach the same thing? It's not so. Maybe most of your papers may look same, but the intention of creating those courses are totally different. If you take computer engineering, I'm not talking about CSC, just computer engineering, it is more of hardware related content. So anybody who is working directly with a component can be called as a hardware engineer. Next, system software content is covered a lot in computer science courses and computer science engineering courses. It can be BSc computer science and it can be B.Tech or BE computer science and engineering. In order to develop new products or in order to make new inventions, you use the term engineering. So making something is engineering. Previously we were using simple calculator for our purpose. Technology is when we upgrade to scientific calculator. So you can be technically updated or upgraded, but once you have the practice of creating something, that is engineering. So both computer science and computer science engineering will concentrate on system software content. System software doesn't mean you have to learn about a particular OS. Whatever is needed to interact with the hardware, every content will be covered there. So system related software, in short, we can say. What about application software? So computer applications courses and IT courses fall under this category. People used to say BCA courses or MCA courses are more job oriented. The reason is industry is preferring application software layer people. This will talk about how to develop something, and this will talk about how to use something. User related and information processing software come under this category. So if I want to get a work done and I need a software for that, it comes under application software. So now you can just recollect certain units. If you want to learn more about hardware, how it works, you need a unit called computer architecture. They will be telling us computer organization and architecture, how to organize them as well as what is the architecture. Then you have data structures, how to store them and what kinds of algorithms they should use. And then we have OS content, then how networks are working. Everything will form under core CS paper. So not only this, how programming happen, then how computation takes place, how machines are created. There we have theory of computation. When you take these topics, most topics will be available in computer applications as well as computer science. If there is a DBMS paper, concentration in application software will be learning MySQL, learning Oracle. Based on this, the subject will be taught. but handling DBMS is not restricted to a specific software in computer science and computer science engineering courses. So when it is specific to some software, this becomes application course. When it is specific to the content itself, it becomes science course. So that's why they say science related people are welcome more for research purpose. And we talk a lot about maths, right? So maths will have a lot of importance in this particular courses. I am just telling you that this is a possibility where you can understand what is available in different courses. Now, let's have a overview of what is going to be dealt in digital electronics content. We have three major topics: number systems, Boolean algebra, and digital logic gates. And under digital logic gates, we have three kinds of circuits that will be discussed in detail. Boolean algebra tells you the mathematical description that is needed for digital logic gates. And these circuits give the hardware implementation of a particular circuit or a particular electronic part that is needed. So the mathematics part is given in Boolean algebra and the hardware part is given in these three topics. What about the number system? In order to work with all those things, you need to have an idea about what kind of number systems is used. So we know computers understand only 0 and 1, but what else is available will be dealt in number systems. So we will be starting digital electronics content with number systems. We will not immediately cover all these topics, but eventually we will cover all these topics. This is all for the introduction of digital electronics. I'll meet you in the next video. Thank you, viewers.